Our study today is about translation. First of all, before we start, I'm going to talk about the popular parent curves. Parent curve is the initial curve. We have y equal to x, which is a straight line. If x is 0, y is 0, x is 1, y is 1. Absolute value of x, if x is minus 1, y is 1. If x is 0, y is 0. If x is 1, is 1. You have a V shape. The parabola, these are some particular points. You have y equal x cubed. This is the shape of x cubed. 2, 8, minus 1, minus 1, 0, 0, 1, 1, minus 2, minus 8. Square root of x, this is the shape. 0, 0, 1, 1. If x is 4, y is 2. Y equal 1 over x, this is the shape where you have a vertical asymptote, horizontal asymptote. So these are the most popular parent curve that we know. Now we're going to start by transformation. You took this in grade 9 before. So we have what's called vertical. Suppose I'm going to add to f of x to y, not to x. You have what's called here x, and where we have, and we have x and we have y. Here I'm adding not to x to k to y. I'm adding k to y. In other words, I have y plus k. So in this case, as if I have components x, y, x remains as it is, and y, f is y, I'm adding to y a k. Here, when you add to y, it means rise or going up or going down, because y is elevation. So in this case, if k is bigger than 0, you have a vertical upward transformation or translation by k. If k is negative, you have a vertical downward transformation by k. If I take this example, suppose you have f of x, which is the black curve parabola. The red one, I'm increasing vertically upward by 2, so it will be f of x plus 2. The blue one, I'm going down by factor of 3. So this is f of x minus 3. As you can see here, I'm not changing x. X is the same for all, but I'm changing the y. We have what's called also horizontal. Horizontal when we are adding to x, not to y. I'm not adding here, but inside. For example, if you have x squared, f of x equal x squared, I'm adding inside x, inside the square. Okay, for example, plus 1. Adding to y, I put it outside. If you have absolute value of x, I'm adding to x, it means, for example, inside the absolute value, plus it will be outside. This is here the y, here I'm adding to what? To x. So here, if I'm going to add to x, just the opposite, first of all, it's horizontal. If k positive, we don't go to the right, we go to the left, just the opposite. Why? Because if you equate x plus k to 0, you have x equal minus k. So that's why always we take here the opposite. So if k is positive, it's a horizontal transformation to the left. If you're putting k negative, for example, x minus 2, for example, square, suppose you have a parabola, so you go to the right, because this is negative, you do the opposite. So horizontal transformation to the right by k. If you take this example, suppose I have this black curve at the initial one. Here, as you can see, the red, I went to the right by 2 units. So it will be, because I went to the right, it will be x minus 2. This is the red one. For the black, I went to the left. For the left, it means even it's toward the left, so it means it must be positive here. So we went plus 3 units, so x plus 3. So as you can see, adding to x, it's just the opposite way of adding to y. Adding to y, if positive, you go upward, vertically, negative, you go downward. Adding to x, if it's positive, you go to horizontally to the left. If it's negative, you go horizontally to the right. Some examples. So let us see this one here. What do we have? We have, first of all, I'm adding to y here. This is the parent curve. The initial one is x squared. You all know y equal x squared. I'm going up 3 units up. Then I'm going minus 2 units to the right. So as if here we have xy, it will be, for x, it will be, I'm adding to the right, it means plus 2, I put the opposite. And for y, I'm putting y plus 3. So here in that case, if you the y equal x squared, which is the parent curve, the particular points, you can use 0, 0, minus 1, 1, 1, 1, because it's a parabola. No, you can use 2, 4, minus 2, 4, whatever, but these 3 points are more than enough because I know the shape of a parabola. So now I want x plus 2, y plus 3. If I replace x by 0 and y by 0 here, I get the image of this point is 2, 3. You can see it here. This is the initial one, the parent curve. Now this is 2, 3. If you have minus 1, 1, minus 1 plus 2 is 1, and 1 plus 3y is 4. So the image of this point here is that point, 1, 4. And the last one, 1, 1, the image, if you replace it 3 and 4, this is 3 and 4, as if I'm rising up the curve by 3, as we said, for every point, and going where 2 points. Okay, here going 3 to the right 2, going 3 to the right 2. So this curve, the green one, will be the red one. Another example. So here what I'm doing, I'm going down by 2 vertically because I have minus 2, I'm adding to y, and then going to the left because plus 3, as I said, opposite. So for x, I put x minus 3, and for y, y minus 2. Root x, these are the components, the particular point 0, 0, 1, 1, root 4 is 2. So if you replace x by 0, y by 0, you have minus 3, minus 2. So 0, 0, its image minus 3, minus 2. So going, as we said here, 3 units and going 2 units down. If you put 1, 1, you're going to get minus 2, and 1 minus 2 is minus 1. So this point 1, 1, you go 3 units to the right, and then you go 2 units down. Sorry, you go 2 units to the right here, 3 units to the left, and then you go 2 units down. So you have this point, and this point here, you go 3 and 2 units down, you have that point. So as we said, you can check by these points. Here, suppose I have a graph, it's not a parent curve. I want f of x plus 2 plus 1. So as you can see, you must go upward by 1 and to the left by 2. So up 1 and 2 to the left. So let me take some points here. You can take that point, minus 2, 4, minus 1, 1, 0, 0, 2, 2, and 4, 2. So as you can see here, x minus 2, because you're going to the left, you just put the opposite of that one, and y plus 1. If you replace x by minus 2, you have minus 4, and 4 plus 1, 5. So this point, which is minus 2, 4, minus 2, 4, let me take it here. This point, minus 2, 4, its image will be minus 4, 5, minus 4, 5, this is its image. And the image of this point 1, 1, it will be minus 1, 2, 1, 1 that I have here in this one, here 1, 1. So its image will be minus 1, 2, okay? And so on 0, 0, this point here, the image will be, if you replace by 0, 0, minus 2, 1. So the image of this point is minus 2, 1, okay? 2, 2, which is here, 2, 2, its image will be, if you replace x by 2 and y by 2, you have 0, 3. And the last one, you have 4, 2. If you replace x by 4, 4 minus 2 is 2, and y by 2, 2 plus 1 is a 3. The image of that point is that point. So what did we do? We translated 2 units to the right and 1 unit up for every point. Now this was translation. Now we're going to go to something else. We're going to start by stretching and compressions. Compressing and stretching. Compressing, you can use also shrinking. Here when you multiply by a number. So let me start by multiplying the y, not the x, outside. So here if you multiply by a number, if this number bigger than 1, you're going to stretch it vertically. You stretch the curve vertically from both sides. Suppose here you have the x-axis, you stretch it up by a factor of a. For example, if you have here factor 2, and if you have a point 3, it will be 6. 3 times 2, if its elevation was 2, it will be 6. You search it from up and down, where you have the limit is the x-axis. And if a between 0 and 1, the curve compress. Compress, it means, suppose this is the x-axis, it will compress, it will be smaller. It's compressed from all sides toward the x-axis. Okay, and if a is negative, because a here you have, for example, minus f, it will be symmetric with respect to the x-axis. So if minus is for y, it will be symmetric for x. If minus for x, it will be symmetric with respect to y. Because here I'm multiplying for y, so symmetry with respect to x-axis. So if I want to write it as xy, if you have a, so here I'm multiplying y by a, and I'm keeping x as it is. And if I have it that form with the translation that we did before, so here this is f, this is y, f and y, it means y. So for y I have a y plus k, a, this is all y plus k, and for x I have, because I have a plus, I put opposite x minus h. Let us take some example. Here, what do I have? First of all, this is parent curve is radical x, as you can see. For the y, let me start by the y. It's 2y, this is all y, minus 3. And for x, you put x plus 2. So we start, suppose you have, how do we start if I want to write all steps? Suppose take x any value, for example, 10. You start by 10 minus 2. So you start by a horizontal translation to the right by 2. Then after doing 10 minus 2, you have 8. You multiply it by what? By 2. Since you multiply it by 2, so here we have a vertical stretch by factor what? 2. Then you add minus 3. Minus 3, it is vertical downward translation by 3. These are the steps. If I want to write it step by step in English, what's happening? If I want to write it arithmetically, directly, it's 2y minus 3 for y, and for x, it's x plus 2. So now, the particular point for radical s, I'm going to use radical x 0, 0, 1, 1, 4, 2. If you replace x by 0, here you have 2. If you replace y by 0, you have minus 3. For 1, 1, you're going to get the 3 and minus 1. And for 4, 2, you're going to get 6 and 6, and here you have 2 times 2, 4 minus 3 is 1. So this is the parent curve radical x. So now you have 2 minus 3. The image of this point is a prime. You can see it here. The image of 1, 1 is b prime. The image of c is c prime. Another example, suppose I have this one. Here it's a minus, if you can see it. So first of all, the parent curve is x squared. If I want to write it directly, this is the whole thing is y. It will be minus 1 over 3y squared plus 1. Minus 1 over, this is all y. Minus 1 over 3y plus 1, as you can see. And for x, you have minus, so you take it to the right, x plus 2. If I want to write it in English, first of all, if x, for example, was 6, you do first of all 6 minus 2. So first of all, you have horizontal translation to the right here, to the right by 2. Okay, because I have minus 2, so plus 2. Then when you square it, you multiply it by minus 1 over 3. So you have the minus. The minus is for the whole y. So symmetry with respect to x-axis. Then 1 over 3, so it's compressed. It is a vertical compress or a shrink by a factor 1 over 3. Then at the end, I add the plus 1, so it's a vertical upward translation by 1. So as we said, this is all y, because this is x squared, y equal x squared. So it's y or minus y over 3 plus 1, and for x is x plus 2. The parent curves particular points for x squared, you can take 0, 0, minus 1, 1, 1, 1. If you replace 0, 0, you're going to get 2, 1. So the symmetry of this point A, it will be 2, 1. If you take minus 1, 1, that you know, if you replace it here, you're going to get 1 and 2 over 3. Y is here 1. So 1 plus 1 over, so here x is minus 1 and y is 1. So this is minus Considering minus, you're not saying well. So minus 1 over 3 plus 1 is 2 over 3. So the symmetry of minus 1 and 1 will be 1, and 2 over 3 point B. And if you have 1, 1, the last one, it will be 3. Minus 1 over 3 plus 1 is 2 over 3. So the symmetry of the point C is C prime. So this is the green curve is the image of the red curve. Now I'm going to go to horizontal. Horizontal, like we did above, in translation, you multiply x by a. So here just the opposite. You remember, while in translation, if you put x plus 2, you go to the left. Here, if you multiply by a number bigger than 1, as if dividing horizontally by a factor of a. So just the opposite. And if a between 0 and 1, so it will be stretching by a factor of a. And if a is negative, because I'm putting minus for x, it will be symmetry with respect to y. So here in that case, if I have product of ax, I'm multiplying a, as if I have x over a. I divide. Multiplication will be division. Division will be multiplication, and y as it is. And if I have a combination with translation, we said that this is all y. So I have y plus k, and here I start first of step by division. So I do x over a, then I add minus h. Okay, so let us go to application so that you can understand better. So here the parent curve, as you know, this is radical x. So I'm multiplying here. So first of all, I must factorize, because as you can see here, I need to factorize, put coefficient of x in factor. So what is the coefficient of x here is minus 2. So I say this is minus 2. Minus 2x divided by minus 2 is x. 4 divided by minus 2 is minus 2. So I have inside for x, this is the square root, as I said. This is y, not change in y. But for x, first of all, I start by, you have multiplication. It will be, because for x multiplication, it will be division. So it will be minus x over 2. Then I add plus 2. So if I want to write it, the first step here is the symmetry. I have a symmetry with respect to y-axis. Then I have horizontal, I have I have a horizontal compressed by a factor of half. Why? Because factor of half, because I'm multiplying by 2. So I divide by half, and we have a translation to the right by 2, because I have minus 2. So if I take this particular point 0, 0, 1, 1, and 4, 2, if I replace x by 0 and y by 0, I'm going to get 2, 0. So this is the parent curve y equal root x. So I have 2, 0. The symmetry of a is a prime. And if you have 1, 1, you're going to get minus half plus 2 is 1.5. And if you replace y by 1, so y is 1 because no change. So the symmetry of the point here b, it will be 3 over 2, 1, this the point b prime. And if you replace by 4, 2, so you're going to get minus 2 plus 2, 0, and y is 2. So this symmetry of this point C, which is 4, 2, it will be 0, 2. So I have this translation. Describe this graph here. Also, I'm multiplying for x. Since I am multiplying for x, so I must put coefficient of x in factor. So half. I open parentheses, so x. So I must divide minus 1 by half. It will be minus 2, all cube. Okay. So first step I have horizontal translation to the right by 2. Then times 2, because it's half, it will be product, a factor of 2. It's a horizontal stretch. And if I want to write it as xy, so here I have y. This is the whole thing is y. The cube is for everything, no change. But for x, first of all, division, it will be multiplication. So it will be 2x plus 2. So the parent curve, for the parent curve y equal x cube, I'm going to use this particular point 0, 0, 1, 1, minus 1, minus 1. You can use more if you want, 2, 8, and minus 2, 8. But if you know the shape, the shape of x cube, no need to use these points. It's enough the first three. If you replace x by 0 here and y by 0, you have 2 zeros. So the point A will be A prime, the image. If you have 1, 1, you're going to get 4 and 1. This 1, 1 will be 4 and 1. X is 4, y is 1. If you put minus 1, it will be 0, y is minus 1. So this point will be here 0, minus 1, and etc. Now I'm going to give the general formula that summarizes everything I did in this video. So as we said, you must factorize x. You put coefficient of x in factor, and for y you can keep it. In that case, if you have here, this is the whole thing is y. For y is very simple, ay plus k. And for x, if you have times, it will be division plus h minus h. So now I'm going to go directly. I want to graph this one. So let me work inside only. So I put minus 2 in factor. So I divide the inside by minus 2. Minus 2x divided by minus 2 is minus 2. Minus half divided by minus 2, it will be plus half. So now what do I have? For x, because I'm multiplying by minus 2, it will be minus x over 2. And I have plus half, I put minus half, so you can see it here. And for y, this is all y, so minus 3y plus 2. Now, particular point, the parent curve is root x. These are the points of root x, 0, 0, 1, 1, 4, 2. Just replace x by 0, y by 0, you get that point. X by 1, y by 1, you get that point. X by 4, y by 2, you get that point. And so the image of 0, 0 will be minus half 2. The image of 1, 1 will be minus 1, minus 1. And the image of the point C, which is 4, 2, will be minus 2.5. and minus 4. So this is the parent curve and this is its image. The last example, then we finish this chapter. Here I start, this is parent curve absolute value of x. Here I have coefficient of x is minus 1 over 3, so I put it in factor. So what do I get inside for x? If you divide by minus 1 over 3, here it will be minus 1. Here it will be plus 3. Minus 1 divided by minus 1 over 3 times the inverse, because 1 over 3 in denominator times 3 over 1. So you permute it. So for x, what do I have? Because division, I multiply now. Minus 3x plus 3, I put minus 3. This whole thing is y, so minus 2y minus 2. So because I have the parent curve absolute value of x, I take 0, 0, 1, 1, minus 1, 1. If I replace here x by 0, you get y minus 3. Y by 0, x is minus 2, and etc. So the image of 0, 0 will be minus 3, minus 2. The image of 1, 1 will be minus 6, minus 4. And the last one, image of minus 1, 1 will be 0, minus 4. And you have this curve. Thank you for listening. Hope that you understood the transformation, the translation, and the dilation of functions.